All right, so today is the Friday notes. So if you're watching online, which hopefully you're watching on Friday, so you have time to catch up over the weekend. If not, make sure you get it all done. By the way, this is a video, so like if you want to speed me up or slow me down or, rewind me or fast forward me, that's fine. In order to speed me up or slow me down, you can just click on the gear icon and those options will be there. Okay, so also, just so you know, again, this is Friday's notes. I try to move things around, but it kind of messes everything up. So instead what I'm going to be moving around is these notes will not be on the 16th. What we're going to have on the 16th instead is the quiz. I know most of you guys have your language test that day, so I decided to kind of move things around. So what's going to happen is that this day will be some important notes. The 14th is going to be kind of a worksheet day, and I'm also going to put the polar coordinate notes on that day. I'm going to push the quiz back to the 16th. I'm going to bring these polar and rectangular forms of equations. Oh, did not mean to do that. In fact, let's do this. These polar and rectangular forms of equations, that's going to be moved to the 15th. This is going to be moved to the 14th. And your quiz will be pushed back. That's kind of what it's going to look like. So just so you know, so that'll kind of help you guys out for that test. And we'll continue. Remember, you should be getting your test corrections done during this next week. You will get your test back on Monday, so keep that in mind. Remember, it's our last unit for our last grades. Make sure you do well. You guys are already taking care of your absences because you're watching this video, so that's a really great sign. Make sure you keep doing that. Also, make sure you keep checking with me and getting everything that you need. I already on this website have the blank notes, the notes key, and the warm-up blank. I think there's something else, but for this day. So if you want to print out like the notes, the blank notes and the warm-up, that'll probably help you follow along with the notes. All right, speaking of warm-up, here we go. So here's the warm-up. So it says write the corresponding write the corresponding rectangular equation for the given parametric curve. So remember, parametrics are like when you have an x and a y and they're both related to some function of t. Okay, and we are going to change them back into their original, like something like y with x squared or something like that. So that's kind of the goal. So again, the process to do this is solve for t, and then plug that in for the t here. So I'm going to solve this one for t. In order to do that, I need to get rid of the ln, so I'm going to e both sides, which is going to give me e to the x is equal to t, and then I'm going to plug that in for t down here. So now I'm going to have y is equal to 2 times, and instead of t, I'm going to have e to the x, and then keep the squared because that's not part of the t. And then I'm going to go ahead and keep simplifying. So I have an exponent to an exponent here. Whenever you have an exponent to an exponent, they multiply. So now I have e to the 2x. All right, this says identify the conic section represented in the equation below. Then write the equation for the conic section in standard form. So remember, in order to write anything or any of these conic sections in standard form, you first kind of have to identify what it is. This is going to be a hyperbola. How do we know? Because the x squared and the y squared have opposite signs. So it's definitely going to be a hyperbola. And then we're just going to treat it kind of like we treat a circle or an ellipse or a hyperbola from the beginning because they all have the same steps. So again, if you're trying to complete the square, you group your x's, you group your y's, and you send the numbers to the other side. So I'm going to have x squared plus 8x plus blank. And then I know my next one is negative 2y squared plus 4y. So I'm going to go ahead and pull out that negative 2. Now, why am I doing that? Because you really can't complete the square unless you have a positive 1 coefficient in front of your square is equal to, and then 8 is on the other side plus my 2 blanks. All right, and then what goes in the blanks? Well, let's think about it. This is going to be 8 divided by 2 squared, so that's 4. Oh gosh, that's not 4, it's 16. Let's fix that. Right, because 8 divided by 2 is 4. Square that, it's 16. Here we go, next one. Negative 2 divided by 2 is negative 1. Square that, we've got positive 1. And then I'm going to put 16 here and not positive 1 here, right? Because this is, what have I really done to this whole side? I've added a 1 inside of the parentheses, but imagine if I were to, distribute, what if I added to this whole side? I've added a negative 2. So I need to add a negative 2 over here. So that is overall going to give me x plus 4 squared minus 2 times y minus 1 squared is equal to, and then what do we have here? We have 6 plus 16, so that's 22. Now, again, we know it's a hyperbola, so my goal is not to get rid of this 2. There will be numbers on the left-hand side. There's nothing I can do about that. My goal is to get rid of this 22, so I'm going to divide both sides by 22 to make the right-hand side 1. 2 over 22 is 1 over 11. And there we go. There's our standard form. Next one, so this says the graph of y is equal to p cosine qx plus r from -5 to 14 is shown below. Minimum at 0, -3, maximum at 4, 7. So p, if we look closely, p is kind of like your vertical stretch and also your vertical flip if need be, which we should already know there's going to be a vertical flip, right? Because if this is a cosine function, what is cosine supposed to do? It's supposed to start on the y-axis high and go low, but what is this one doing? It's starting low, so I already know this is going to be negative. All right, then moving on. Q is the horizontal stretch or shrink. And we use Q when finding the period. In fact, the formula looks like this. Period is equal to 2 pi divided by Q. We usually call it B, but they're just calling it by a different name here. All right, and then R. R is the midline. That's the line that goes right through the middle of your graph, kind of cuts it right in half. And it's important for finding the amplitude, and it's also your vertical transition. So in order to find that, I really need to know the average of my two y values here, the maximum and the minimum, because the one in between the maximum and the minimum will be right in the middle. So I'm going to go do that first. So I'm going to do my average formula. So it's 7 plus -3 all over 2. And that's my r. So that means this line is at y is equal to 2. All right, then I'm going to go find my p next because this helps. So what I know is that the distance from this point to this point is my amplitude. Oh gosh, that's bad. But from my midline to my maximum is my amplitude. So from 2 to +7, that's the y distance. So that's going to be a distance of 5. So that's going to be my p here. Again, it's negative because it's a vertical flip. And then q, I'm going to have to solve for. So I first need my period. Well, what's the period? It's the length from minimum to minimum or maximum to maximum. I'm going to do minimum to minimum here just because that's easiest. So now here's the deal. I know this distance. This distance is 0 to 4. So it's 4. I don't know the whole distance though, but that's okay because it's just double. I went from the maximum all the way back down to the minimum, so this is another 4. So I'm going to have my period is 8. So I'm going to say 8 is equal to 2 pi divided by q. And solve for q. I can swap these two, so I can say q is equal to 2 pi divided by 8, which is equal to pi divided by 4. And that's my q. All right, that's it for the warm-up. Now let's move on to equations with particle motion. All right, so particle motion is a lot like the projectile motion that we talked about yesterday in class, where x of t is your horizontal motion and y of t is your vertical motion. Okay, and we're going to have those still, right? But we're also now going to have x prime of t and y prime of t. Those are your velocities. That's your horizontal velocity and your vertical velocity. And just like particle motion, being positive or negative means different things, and being 0 means a different thing as well. So if x of prime of t and y prime of t are both 0, so that means you're not moving horizontally and you're not moving vertically, that means your whole particle is at rest. Okay, and then if the particle is moving left, that means that your horizontal velocity has to be negative, right? Because it's a negative motion. Or if it's moving right, it's positive. And then upward and downward, those are going to be positive and negative as well. Ooh, whoops. Did not want to do that. I wanted to scroll down. And again, why is this useful? Because let's say you're making a map from your home to your work. Okay, and you take this road here, and then you take this road here, and then you take this road here, and then you take this road here. All right, so that's your x position and your y position. Okay, that's really useful. Like if you're handing a friend a map, you probably give them something similar to this, hopefully better looking than this, but similar to this at least. And that's very useful. However, a lot of times we don't just want to know where something can go, we want to know when it will be there. Yeah, like so if this is like, let's say you just ordered pizza and they handed you this map. You would say, okay, but when will my pizza be here, right? So that would be your question. You want to know about that third variable. You want to know about the time. So we have the x and y position, but we don't know about the time. That's where parametric equations come in handy because they tell you the x distance over time and they tell you the y distance over time. So like if you know when your pizza man is going to arrive here, you would just have to find the t when y is, you know, whatever value this is. We could say 11. And x is this value here. We could say 10. So you'd just be trying to solve for that equation. So that's pretty useful there, and we'll move on, but that's the idea. All right, so this has determined the position of the particle when t is equal to 3, and it's given us an x position, a y position, an x velocity, and a y velocity. So I can go find that information. So first thing I'm going to do is determine my my x position and then my y position. Those two positions together will give me my total position. So my x position, oh, I don't want x of t, I want x of 3. So my x of 3 is equal to 3 cubed minus 12 times 3, which that is 27 minus 36, which is negative 9. So that's my x position. Now let's go find my y position. Okay, and again, 3. All right, and what am I doing? I'm plugging 3 into my x position graph, and I'm plugging 3 into my y position graph. That's giving me what I need. So it's 1/3, 3 cubed minus 2 times 3 squared plus 4 times 3. So what is this? This is going to be 27 divided by 3, which is 9. 9 times negative 2, which is negative 18. And 4 times 3, which is 12. Altogether, this is going to make 3. All right, so that is my x position and my y position. And when I want to write that all as a point, here's how I can say it. I can say at t is equal to 3, the position of the particle, and you don't need to say like is horizontally negative 9 and vertically positive 3. You can just say negative 9, positive 3. So this would say like, oh, at 7:30 your pizza man is going to be right here on this street at this time. That's kind of like what you did there. So that's what that looks like. Let's try another. Oh, by the way, remember, always with particle motion, you got to be writing this out in sentence format. This answer is not enough. You have to go write it out in sentence format, so keep that in mind as we go. All right, this has determined when the position of the particle is at negative 11/7/3. Oh, that's like the question I asked earlier. Okay, yes, but when will the pizza man be at my house? So how do we do this? So I need to know when my x is equal to this and when my y is equal to this. So what am I going to do? If I want to know when x is equal to negative 11, I'm going to set x is equal to negative 11 and solve for t. That's exactly what I'm going to do. So let's try it out. So negative 11 is equal to t cubed minus 12t. All right, and we're also going to do it for the y. So I'm going to say 7/3 is equal to my y position. Again, because I want to know when my position of my y is 7/3. And then you're going to find both of those in your calculator. And again, you're going to do that by doing y1, y2, and setting and finding their intersections. And then you go enter, enter, enter. You got to make sure that you are nearby the intersection that you want though by doing arrow keys. So you'll go left and right till you get close and then you'll do enter, enter, enter. So let's try the one with the Y position. Hold on, am I recording? Good, okay. Thank you, sorry. All right. It'd be a real bummer if I hadn't been. Here we go. I'm going to go ahead and turn my calculator on, and I think I already have this saved in here for you guys. Yes, I do. So this is my Y1. That's this Y position formula here. And what do I want it to be? I want it to be 7/3. So when I graph them, I get a graph that looks like this. Of course, I've changed my window. I knew I was looking for it to be 7/3, so I made my Y minimum pretty small, my Y maximum pretty small. All right, and then I found the intersect. Here's how you do that. You go second, calc, intersect, enter, 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 and lo and behold, there it is. So this one here tells us that x is equal to 1. Okay, and if you do the other function, you're going to get some intersects too. You're not just going to get x is equal to 1. You're going to get negative 3.854, 1, and 2.854. Okay, so the question is, what is our answer? Is our answer all of these? Is it none of these? Is it just one of these? How does it work? Okay, so if you want to know where your pole position is negative 11, positive 7/3, that means you must have one time, or multiple times, but you have to have a time that satisfies both conditions. Your x has to be equal to negative 11 and your y has to be equal to 7/3. So that means our only answer can be the one in common here. X is equal to 1, and that would be your final answer. And then we would write it out in the correct form. So I would say the position of the particle is negative 11, positive 7/3 when t is equal to 1. Notice I didn't say x, right? Because the real value it's looking for is t. So, and I said x is here because that's what the calculator says, but even these really should be t's. So something to keep in mind as you move forward. All right, this says for what values of t is the particle at rest. So in order for the particle to be at rest, your velocities have to be 0. So I'm going to set both of my velocities equal to 0. Again, these are my velocities. They both need to be 0. Okay, and then I'm going to solve for them to be 0. Notice you can't use a calculator on this one, so we're just going to have to do it the old-fashioned way, factoring. Okay, once we have them factored, we can go ahead and solve from there. So, oh, and this one's not fully factored yet, is it? I need to do my difference of squares. Oh, that means I messed up. I can go over here and fix this. I bet someone was thinking, Mrs. Nicholas, that doesn't work. You'd be right, it doesn't work. There we go. All right, so now they're factored correctly and I can go find my t values. So this one's giving me a t value of 2, this one's giving me t values of negative 2 and positive 2. So again, if I want to know where the particle is at rest, that means that you can't have either, really you can't have neither your horizontal motion or your vertical motion. They both have to be 0 in order for the particle to be completely at rest. So that means my t values are going to have to match, right? Because not all, they can't just be one is 0, they can't just be this one is 0 or this one is 0, they both have to be 0. That only happens when t is equal to 2. When t is equal to 2, y is 0. When t is equal to 2, x is 0. Bam, both conditions met, and we can write out our sentence. So here's our sentence. It goes like this. Since x prime of t is equal to 0 and y prime of t is equal to 0 at t is equal to 2, the particle is at rest at t is equal to 2. There we go, it's done. Next one. For what values of t is the particle moving upward? So if the particle is moving upward, we're talking about motion and it's positive. So and not only is it positive, it's your vertical. So what does that mean? That means I need y prime of t to be greater than 0. Okay, because I'm wanting my movement to be positive and vertical. So that means y prime of t has got to be greater than 0. So that means I need to solve this inequality here. It means I need to solve t squared minus 4t plus 4 is greater than 0. Well, that's a polynomial inequality. It's a nonlinear inequality. You might remember how we solved those, or you might not. We're going to do a refresher, but you have to use sign analysis. Please do not try to use linear methods on this. It will not work. You're going to end up with nonsensical answers. So instead of doing that, we're going to kind of do a demi-graph by doing sign analysis. Okay, so in order to do that, you first have to find your critical values. Okay, remember critical values are where you are 0 or undefined. So in order to find those, you're going to set your equation to 0. Remember, it's a polynomial, so we're not going to have any undefineds because it has an infinite domain. So we're just going to say t squared minus 4t plus 4 is equal to 0 and solve that. And of course, we already solved that, and we got t is equal to positive 2. So once we know that, we can do our sign analysis, our little graph here with our critical value at 2, and then we can go find our other values. So I need to choose some testing values. So I'm just going to choose like negative 10 and positive 10, because why not? Remember, they just have to be in between your testing values. And then I can plug them into my original function. Though really, you shouldn't even have to plug them into your original function, right? Because you know the end behavior. If you think about your 4 core, it's both positive and even, so it's going to be positive and positive. Or you can test your values, both ways work, okay? And we chose our testing values because, well, negative 10 is less than 2, and when you plug it in, what happens? We get 100 minus 40, or sorry, 100 plus 40 plus 4, which is definitely positive. Same thing for positive 10. Okay, so let's do the next one. All right, so this next one says, for what values of t is the particle moving to the right? Justify your answer. Okay, so in order to find that, I'm going to go find where my horizontal motion or my horizontal velocity is positive. Okay, so here's how I'm going to do that. I'm going to take my x prime of t and first find the critical values. So I'm going to say 0 is equal to 3t squared minus 12. And of course, we already know the solutions for that are t is equal to plus or minus 2, so negative 2 and positive 2. So now, if we want to know whether it's moving right or moving left, we're going to have to do the sign analysis again. So I'm going to set it up. And then I'm going to choose my testing values. Okay, so when I'm choosing those testing values, let's see, when we plug in negative 10, what do we get? We're going to get positive. When we plug in 0, we are going to get negative. And when we plug in positive 10, we are going to get positive. Remember, because like if you plug in negative 10, what are you getting? You're getting 300 minus 12, which is positive for sure. Okay. Also, you could tell from the end behavior of this graph. Again, your 4 core. It's positive, it's even, so it's going to go up on both sides. So you know that both of these are going to be positive. And then these aren't tangencies, so it won't bounce, so it'll change signs right here. All right, and then we're going to write it out in a sentence structure. So I'm going to say, let's see, what was I saying? Moving to the right. So I want where it's positive. So it would be negative infinity to negative 2 and positive 2 to positive infinity. So when I write it out, I'm going to say since, what is it, x prime of t? Is that what we just did? Yes, x prime of t. Since x prime of t is greater than 0 on negative infinity to negative 2 union 2 to infinity, the particle is moving to the right on negative infinity to negative 2 union 2 to infinity. All right, and I think did I do the sentence structure on this one? No, so let's go back and do the sentence structure on this one. So again, we're looking for is moving upwards, so that's where it's positive. So it would be negative infinity to positive 2, positive 2 is to infinity, basically everything but 2. So I'm going to write it like that. So since y prime of t is greater than 0 on negative infinity to 2 union 2 to infinity, the particle is moving to the right, or sorry, upward. Oh, so I don't want 2. Is moving upward on negative infinity to negative, or sorry, yeah, negative 2. No, I don't want that. Going crazy here. Negative infinity to positive 2, union 2 to infinity. All right, there we go. That's better. All right, and then our last example is this guy here. It says, for what values of t is the particle moving upward and to the left? So that means our y prime of t is greater than 0, and our x prime of t is less than 0. Again, because it's moving in a positive direction up and down and moving in a negative direction left and right. So that means I'm looking for where it is moving up and moving to the left, which means my y of t has got to be positive, so I'm looking for these guys here, and my x prime of t has to be negative, so that's this guy here. So the only place where these correlate, so where both are happening at once, is from -2 to +2. It's this area right here. All that time from -2 to +2. Both of these, or that y of t is positive and x prime of t is negative. So I will write that out. So I will say, by the way, I just copied these from the last few pages. So since y prime of t is greater than 0 and x prime of t is less than 0 on our current interval, -2 to +2, the particle is moving upward and to the left on -2 to 2. And that would be our final answer. And then that's pretty much it for the notes. Make sure you print off your homework and work on that, or you can come get your homework from me after school on Friday. But other than that, you should be all set. Okay, guys, have a wonderful day, and make sure you're keeping caught up, and good luck on all your tests. Have a wonderful night.